In this session, we are going to focus on reaction schemes, that is organic chemistry. And when you're dealing with reaction schemes, you are simply referring to the roadmap to a certain chemical reaction. So, in this segment of this topic, you simply deal with how a reaction is going to take place. You're just trying to form a plan on the reagent you must use, under which conditions you must apply for that reaction to be successful, and also the yield or the product which you're going to get after that chemical reaction becomes successful. So this is what we are mostly interested in. Per se, you're not doing the actual mechanism of the reaction, but you are trying to plan and also see the possible things you must put into consideration for that reaction to take place. So let's get into it. So reaction schemes. Okay, so we've said that this is just a roadmap. A roadmap of a chemical reaction. And mostly what we focus on what to use in a chemical reaction, the reagents, and also the product. So we are focusing on the reactants to use. After the reactant, we focus on the reagents to use. Apart from reagents, we focus on the products. But before we even look at the product, we must focus on the conditions. Okay, and sometimes these two can be referred to as one and the same thing, reagents or the reactants. So conditions are so much important, and also the products which we are going to yield. So let me just give you an example. Let's just look at an example or the basic format of this reaction mechanism. So the basic format, you can look at this example. Basic format. Okay, basic format of a reaction mechanism. So the basic format would be the reactants, then here you put the reagents which you're going to use, and also it could be you have the solvent, or maybe you can put the conditions you must apply, then what will be the end product after the reaction is successful. So this is the basic format of a reaction mechanism. So you might try to ask ourselves, like, why do we need to use these reaction mechanisms? So the importance of a reaction mechanism, or reaction scheme rather, sorry. Okay, the importance of this reaction scheme, we are trying to show the reagents and conditions. We are trying to show the reagents and conditions which are necessary for the reaction to take place, other than that, we are trying to plan. So these reaction schemes are used by chemists so that they are able to plan on how the reaction will take place. So for planning purposes, and also in exams you might be asked to write and interpret the reaction mechanism. And using the reaction mechanism, it is a clear way of outlining how a certain reaction is going to occur. So it's a clear outline of a reaction. Alright, so now let's look at examples of reaction mechanisms. So we might be asked in most exam papers, they will usually say predict the reaction scheme. Predict the reaction scheme. Then we'll be given a certain reactant like this one. So this is benzene. We'll be given a benzene. Then they'll show what we are getting. In some cases, they'll show the reagents, then they'll ask us to predict the product. So those are two different scenarios we might be asked. So we'll have this benzene ring in this form. Now they have shown us the products, a bromine attached to the benzene ring. We have a carbon, then we have a methyl there, CH3, and also a 3 outside. So this is just a question from a tutorial sheet. Then we have SO3H. So we are asked to predict the reaction mechanism. So from benzene, how are you able to form this product? So we are trying to plan what should we use as reagent, under which conditions, so that this reaction is successful. So let's get into it. So I'll try to use a different board. Okay, so we have our benzene ring. So we have our benzene ring like this. So we are trying to form a product which is of this nature. So our product has a carbon there bonded to CH3 with a 3 outside like that. So we have our bromine there, then our SO3H there. So how are we going to perform this reaction using a reaction scheme? So our first step will be, we'll see that this benzene on top, it is attached, or on the para position rather, it is attached to C open bracket CH3 then close bracket 3. Okay, so we can perform first a certain process known as alkylation. So with alkylation, we are trying to add an alkyl group to this benzene ring. So you can see that on top it was just an alkyl group which was added. So we'll use the reagent which contains an alkyl. Okay, so basically which is what we are going to use. So we can use any halogen bonded to an alkyl. the halogen will be just there to stabilize the alkyl group, and we know that halogens are better leaving groups. So any halogen we are going to use, for example bromine or maybe chloride, is going to leave easily. So we can use chlorides attached to this same group, which is C open bracket CH3, then with a 3 outside, like that. So this reaction occurs in an environment where there is aluminium chloride, and the product you're going to form could be of this nature. So you're going to form this product. So we'll just have a carbon bonded to CH3. Okay, so we're going to form that. Well, let me just use a different ink so that we have a clear picture. Okay, so this is what we are going to form. C open bracket CH3, then with a 3, like that. Then we're going to do another reaction here. So you can see that what was added at the bottom on the same para position, it was a sulfate. So this reaction had to undergo what is known as sulfonation of benzene. So they had to perform sulfonation of benzene, and we know that for sulfonation to take place, there has to be two sulfuric acid reacted together so that we can form the SO3H, which is positively charged. This group then added to the benzene ring. So this is the electrophile which was added to this benzene ring. They had to perform just sulfonation reaction. So meaning that we are going to use the reagent which are involved in sulfonation. So we'll have SO3H bonded to, reacting in the presence of sulfuric acid, because this is just sulfonation which took place here. So as we are just interested in the reagents so that we come up with the product, so it will be H2SO4, like that. Then the reason why we are using this, it is because we want to block the para position. Okay, so now the product we're going to form is going to have something of this nature. So we're going to have, of course, in the first case we had this CH3, C open bracket CH3, then okay, let me just like that. Then at the bottom here you have SO3H. Now to form this bromine there, or the bromide rather, they had to do this reaction. They had to perform a reaction which is known as bromination. So they added a bromine, and this is still alkylation. So they had to perform this type of alkylation by adding the bromine on this position, which is just the meta position if you are considering the orthopara meta positions. So the reaction you're going to perform is just the alkylation. So you're going to use bromine, then it will react in the presence of this iron bromide, or let me call it iron 3 bromide. Then what we are going to form now is this this product. So at the bottom there we have SO3, SO3, okay, SO3H. Let me just write it properly. So SO3H. Then at this position we have now a bromine. Then at that position now we have C open brackets CH3, the 3 outside like that. So we have formed the product which we are interested in. So you can see that this is how they had to plan this reaction so that they arrive at this product of interest. So basically this is how you perform the reaction scheme. So this is a reaction scheme where we have now assigned the certain reagents to add to the reaction at a specific step. So it's more like a stepwise way of dealing with a chemical reaction. How are you going to perform the chemical reaction? By following a step-by-step synthesis. Alright, so let's look at another question which was asked in the tutorial sheet. So for this particular question, they had to give us a benzene ring like that. So we are given a benzene ring, then they formed a product of, okay, so they had to form this particular product which was of this kind. So they formed this particular product. We have Cl open brackets, then CH2, the 3 outside there. Then there we had a bromine. So how was this reaction performed, or how are we going to perform rather this reaction? So we need to outline now the reaction scheme so that we can arrive at this product. So let's see how we can perform this reaction. Alright, so the first step will be addition of this group there which is on top. So to add that group on top, we are going to perform alkylation. So we're just going to say a chloride attached to that group, which is just CH3CH2, okay, CH3, the 3 outside like that. But if we can draw this structure in a skeletal manner, we can just say it is a structure which is looking like this. So we have a chloride there, then it is bonded to something of this kind. This is the structure for this particular compound. So you can see that there are 3 carbons, so 1, 2, 3 there. Then there are 6 hydrogens. If you count here, there are 3. Then plus this hydrogen there. So there's 1 hydrogen here. Then there is another hydrogen there. So how many hydrogens so far? So 3 hydrogen here, then 4, then 5 hydrogen. Okay, so we have CH3 with a 3 outside there. So we have 3 carbons, then 9 hydrogens. So we must make something which has 9 hydrogens. So it will be something of this nature. So you can just say a group, this in skeletal form, it will be something of this kind. Okay, so let me write it in this manner. So we have 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7. Then okay, 7 plus. So here there are 3. Here 2. So that is 5. Here 6, 7. Then there I'll have 7 plus 3, that will be 10. So to minimize, there has to be a double bond somewhere. Let me put a double bond here. So I'll have 1, 2, 3, 4, okay, 5 plus the 3 which are here. So 3 plus 3, that is 6. 6 plus 2, that is giving it's giving what should be 8. Okay, so this is just a group which is on top there, which is we are trying to draw in a skeleton. So it is just a chloride, then bonded to 3 methyl. Okay, so it's just something of this kind. Okay, so this is what we have there. Alright, so we can now perform the reaction mechanism. So we're going to use the same, just a chloride attached to a group of this nature. Okay, so this is what we basically have, and that was CH2 3. So CH2 3, that is 3 carbons and 6 hydrogens. So it is simply the same group, which was just like this, because here there are 3 carbons, here 3 carbons, then with this I mean here 3 hydrogens with these 2 hydrogen, making them 6. Okay, so it's just 6 hydrogens then with 3 carbons. Alright, so we can now have something of this kind. So we'll have this reaction must occur in presence of aluminum chloride, like that. So we're going to have this group attached. So you can even put it on top. So this is the group which is attached, like that. So we have attached this group. Then the next step will be to remove this double bond here. So to remove the double bond, you can just protonate it. So you can do protonation. So with protonation, you simply need to use something like an acid, okay, hydrochloric acid. Then the double bond will grab this hydrogen, then the bond will break. So what you're going to form now will be something of this kind. So have this, okay, with a positive charge there. Then this positive charge, we can attach a chloride. That chloride which left can come, okay. So the chloride can come and attack the carbocation there, which is going to form now something of this kind. So it's going to form something of this nature. So here we're going to have, oh sorry, just should be 1 2, okay, 1 2, like that. Okay, well, let me just use a different ink so that we can differentiate. So we are going to have this. So there we have attached a chloride, okay. Then the last thing we're going to do here is just for us to do what is known as bromination, because we have already formed this group which is on top. Then we'll do alkylation by adding a bromine. So we'll have to add bromine, and this has to be added in the presence of bromine, iron 3 bromide rather. So when this happens, we're going to form a product of this kind. So on top there we have this group, okay. Then the double bonds which are alternating. Then at this point we'll have a bromine which is attached, okay. So we'll have a structure which is looking like this, and we can see that this group which is on top there, the group which is on top is simply the same group we were given in the question. So this group here is simply the group which is there, except that this is a skeletal structure. But if you want to show it, we can even count. So it is just chloride, then which is attached to, let's count the carbons to see how many there are. So there's a carbon there, 1 2 and 3. So 3 carbons, so C3. Then let's count the number of hydrogens which are there. So the number of hydrogens, we can count where there is carbon there. there are 3 hydrogens, so 3. Here there is 1 hydrogen, 4. Then here there are 2 hydrogens, 6. So C3H6. C3H6, which is just the same as ClCH2 with a 3 outside. So we've seen that these two are just one and the same thing. Okay, so this is how this reaction was performed. So it is just the reaction mechanism on how it was performed. Okay, so we can now do another question. Okay, let's look at another question. So this was asked in an exam. The question was predict the reaction scheme. Predict the reaction scheme. Alright, so the question we have is, we have a benzene ring here. Then it is forming this product. So this was the product. Here with this structure. Then on top we have NH2, like that. So how can we perform this particular reaction? So the first thing, you can see that this reaction has undergone what is known as alkylation. So to add this chain of an alkyl, they had to just perform alkylation. So what we are going to do is, we are just going to count how many hydrogens and how many carbons were added, so that we can put the reagent there. So we can see that here there is 1 carbon, 2, 3, 4. So with alkylation, to form the reagents, start with writing a certain halogen. You can add a bromide or just a chloride, just to stabilize that alkyl chain. So in this case, let's add a chloride. Then you can count that there we have CH2 at this point. Then there also CH2, there CH2. So CH2, CH2. Again, we have CH2. Then with CH3. So we can just try to condense it a bit. So to condense it, we can just write like this. So I'll just open the brackets, then I'll say CH2. Then I'll put, because they are 1, 2, 3, I'll put a 3 outside. Then I'll say CH3 again. Then this reaction has to occur in a medium where there is aluminium chloride. Then once we perform this reaction, at this position we're going to add this alkyl chain, so it will be formed as such. Then the next thing they had to do to this reaction, they added this nitrogen, this nitrite rather. So they had to perform what is known as nitration. Yeah, so they had to do nitration of benzene. So the reagents we use for nitration of benzene, we react a nitric acid with a sulfuric acid. So once we form an electrophile, which in this case will be NH2, then with a plus there. Okay, so this reaction, actually I made a mistake on top. It was NHO2, not NO2, not NH2. So and I said here we do the nitration. So with nitration, we are just going to use the reagents which are used for nitration. So the reagent for nitration, you simply use NO2 plus, then this reaction has to occur in the presence of sulfuric acid, like that. Then we are going to form a structure of this kind. So the structure going to form will be this. Okay, so on top there we have NO2. Okay, so this is the reaction mechanism which was performed in order to come up with this reaction. And as I mentioned to say, on nitration we use nitric acid. Then this nitric acid is, so it has to be 3 there. This nitric acid is made to react with sulfuric acid. So you can check out the video for nitration. That's where it was explained on how the NO2 plus is formed. This is the electrophile. So how this electrophile is formed. Okay. Alright. So basically this is where we end with the reaction mechanisms. Thank you for watching and don't forget to subscribe.
Acha kumaliza.